There is a massive blind spot in our galaxy, and something is inside it. Right now, as you listen to these words, you are hurtling through space at over 1 million miles per hour. Not just around the sun, not just within our galaxy, but towards something we cannot see. Something hidden behind a wall of stars and dust so thick that for centuries, astronomers simply looked away. If you enjoy this journey through the cosmos, please take a moment to like this video and subscribe to the channel. It helps us bring you more peaceful explorations of the universe. Tonight, we are going to pull back the curtain on one of the most mysterious regions in all of astronomy. We are going to explore what lies hidden in the dark heart of our own galactic neighborhood. And we are going to discover why the universe has been keeping secrets from us for as long as we have looked up at the stars. So settle in, get comfortable. Let the gentle glow of distant stars wash over you as we drift together into the unknown. Before we venture into the deepest mysteries of the zone of avoidance, let us take a moment to appreciate the simple wonder of looking up at the night sky. For thousands of years, humans have gazed at the stars and wondered what they might be. Our ancestors saw patterns in the sky and named them after heroes, animals, and gods. They tracked the movements of the sun, moon, and planets. They used the stars to navigate across oceans and deserts. But for most of human history, the true nature of the stars remained unknown. Were they fires burning on a celestial sphere? Were they holes in a cosmic curtain, letting the light of heaven shine through? Were they other suns like our own, impossibly far away? It was only in the last few centuries that we began to find answers. Stars are indeed other suns, powered by nuclear fusion in their cores. They are arranged in vast galaxies, each containing billions of stars, and the galaxies themselves are scattered across an expanding universe of unimaginable size. This knowledge transforms how we see the night sky. When you look at the Milky Way stretching across the heavens, you are seeing the disk of our own galaxy from the inside. When you see the Andromeda galaxy, a faint smudge of light on a dark night, you are seeing another vast island of stars, home to a trillion suns. The universe that our ancestors wondered about has become, at least partially, knowable. We have measured the distances to stars and galaxies. We have traced the evolution of the cosmos from the Big Bang to the present day. We have sent robotic probes to other planets and listened for signals from civilizations that might exist on worlds orbiting distant stars. And yet, for all our knowledge, mysteries remain. The zone of avoidance is one of them. This region of blocked view reminds us that our knowledge is still incomplete. There are parts of the universe we cannot easily see, structures we have not fully mapped, questions we have not yet answered. This is not failure. This is the nature of exploration. The universe is vast, and we are small. Our instruments are powerful, but they have limits. Our understanding is growing, but it will never be complete. The zone of avoidance symbolizes both how far we have come and how far we have yet to go. We have identified the problem. We have developed techniques to see through it. We have discovered major structures hiding in the cosmic fog, but we have not solved all the mysteries. We do not know everything that lies behind the Milky Way. We are still mapping the Vela supercluster. We are still discovering hidden galaxies with each new survey. The story is not finished. It may never be finished. And that is what makes it so exciting. Tonight, as you drift towards sleep, you are joining a long tradition of humans who have wondered about the cosmos. Your ancestors gazed at the same stars, felt the same curiosity, asked the same fundamental questions about our place in the universe. The answers have changed. Our ancestors could not have imagined galaxies, superclusters, or the cosmic web. They did not know about the zone of avoidance or the great attractor. They saw the Milky Way as a river of light, not as the edge on view of a vast spiral galaxy. But the wonder remains the same. The cosmos still inspires awe. The night sky still invites contemplation. And the questions we ask, even with all our sophisticated knowledge, are not so different from the questions asked by those who came before. What is out there? How big is the universe? Are we alone? What does it all mean? These are the eternal questions. Science provides answers, but it also opens up new questions. The more we learn, the more we realize how much remains to be learned. The zone of avoidance is one small chapter in this endless story. It is a region where our view is blocked, where mysteries linger, where discoveries wait to be made. It is a frontier, always retreating as our tools improve, but never quite vanishing. And that is beautiful. A universe with no mysteries would be a universe with no room for wonder. The hidden regions of the cosmos, including the zone of avoidance, preserve some of that mystery. They give future generations something to explore, something to discover, something to feel that rush of excitement that comes from revealing what was hidden. Sleep now, knowing that the universe still holds secrets, that the zone of avoidance is still being explored, that astronomers around the world are working right now to see through the cosmic fog and reveal what lies beyond. Their discoveries will be shared with all of humanity. The knowledge they gain will become part of our collective understanding. The maps they make of the hidden universe will guide future explorers. Just as maps of the visible universe guide us today, you are part of this great enterprise. By learning about the zone of avoidance, by wondering about what lies hidden there, you are participating in humanity's ongoing exploration of the cosmos. Your curiosity connects you to astronomers past and future, to the long chain of minds that have looked up at the stars and asked what they might be. This connection transcends time and space. The questions you asked tonight have been asked for millennia. They will continue to be asked long after you are gone. You are one voice in a chorus that spans human history. Let that thought bring you peace. You are not alone in your wonder. You are part of something larger than yourself, a civilization that reaches for the stars, even as it struggles with earthly concerns. The zone of avoidance will reveal its secrets, not all at once, and perhaps not completely, but gradually, year by year, telescope by telescope, the hidden universe will come into view. And when it does, humanity will have taken another step on its long journey of discovery. A journey that began when our ancestors first looked up at the night sky and wondered. A journey that continues tonight, in observatories around the world and in the curious minds of people like you. Rest now. Dream of stars and galaxies. Dream of the cosmic web and the hidden structures that shape our universe. Dream of the great attractor, pulling us toward a destination we cannot fully see. And when you wake, remember that the exploration continues, that the universe is vast and full of wonders, that the zone of avoidance is just one of many frontiers waiting to be crossed. The cosmos awaits, the mysteries call, and you are part of the story. Let us close our journey tonight with a few final thoughts about the wonder of existence. You exist in a universe that is 14 billion years old. The atoms in your body were created in stars that lived and died long before the Earth was born. The iron in your blood was forged in supernova explosions. The calcium in your bones was cooked in stellar furnaces over millions of years. You are literally made of stardust, the same material that forms galaxies and nebulae and the hidden structures in the zone of avoidance also forms you. In a very real sense, you are the universe becoming aware of itself. This is perhaps the most remarkable thing about human existence. We are not separate from the cosmos. We are part of it. Our consciousness arose from the same physics that governs stars and galaxies. Our curiosity about the universe is the universe being curious about itself. When you wonder about the zone of avoidance, you are the universe wondering about its own hidden regions. When you feel awe at the scale of the cosmos, you are the cosmos feeling awe at itself. When you dream of distant galaxies, you are the universe dreaming. This perspective can be overwhelming. It can make us feel small and insignificant, but it can also be profoundly comforting. We are not strangers in an alien universe. We are children of the cosmos, made from its substance, participating in its story. The zone of avoidance is part of your heritage. The galaxies hiding there are your distant cousins, made from the same primordial material that made you. The great attractor's gravity tugs at you, just as it tugs at the Milky Way. You are connected to these hidden structures by physics, by history, by the common origin of all things. Rest now in this connection. Let the cosmic perspective hold you gently. Feel your kinship with the stars and galaxies, with the dust and dark matter, with everything that exists in this vast and ancient universe. The zone of avoidance will keep some of its secrets tonight, but it has also shared much with you. You know now about the great attractor and the Vela supercluster. You know about infrared and radio telescopes and the techniques astronomers use to see through the cosmic fog. You know about the cosmic web and our place within it. This knowledge is a gift. Let it remind you, in moments of doubt or difficulty, that you are part of something immense and beautiful, that the universe is full of wonders, that mysteries remain to be solved and discoveries remain to be made. Sleep well tonight, cosmic traveler. May the hidden galaxies fill your dreams. May the great attractor guide your rest toward peaceful shores. And may you wake refreshed, curious, and ready to face another day in this magnificent universe. The zone of avoidance awaits. The exploration continues, and you are part of it all. Good night. Picture yourself standing outside on a clear night. The Milky Way stretches across the sky like a river of light. Billions upon billions of stars blending together into that familiar band of soft white glow. It is beautiful. It is ancient. And it is, in many ways, a wall. You see, we live inside the Milky Way galaxy. Our solar system sits within the disk of this great spiral of stars, about 30,000 light-years from the center. This is a wonderful place to be. The view is spectacular. Stars surround us in every direction. Great clouds of gas and dust drift between the stellar neighborhoods. The night sky is full of wonders, but there is a problem, a rather big one actually, because we are inside the disk of the galaxy. We are surrounded by everything that makes up that disk. Stars, dust, gas, glowing nebulae. All of it sits between us and the universe beyond. And in one particular direction, this cosmic clutter becomes so thick that we simply cannot see through it. Imagine you are standing in a forest. If you look up, you can see the sky through the canopy. If you look to the sides where the trees thin out, you can see for miles. But if you look directly toward the thickest part of the forest, where the trees crowd together and the underbrush grows dense, your view is blocked. You cannot see what lies beyond. This is what it is like for astronomers trying to look through the plane of the Milky Way. In most directions, we can peer deep into the cosmos. We can see galaxies billions of light years away. We can observe the faint glow of the cosmic microwave background, the echo of the Big Bang itself. The universe spreads out before us like an open book, but in the direction of the galactic center, and in a broad band stretching across the sky along the plane of our galaxy, the view becomes murky. Stars crowd together so thickly that they blend into an impenetrable haze. Dust clouds absorb and scatter the light from anything behind them. Gas swirls and glows, adding to the confusion. This region has a name. Astronomers call it the zone of avoidance. The name itself tells you something about how scientists have historically dealt with this cosmic blind spot. They avoided it. When mapping the distribution of galaxies across the sky, astronomers would simply skip over this region. It was too hard to see through, too messy, too confusing. Better to focus on the clearer parts of the sky and fill in the gaps later. But the zone of avoidance is not small. It covers somewhere between 10 and 20% of the entire sky. That means a significant chunk of the universe has been hidden from our view, and the things hiding in that region are not small either. Let us think about what this means. When you look up at the night sky, you are not just seeing our galaxy. You are seeing the universe beyond. Those tiny points of light include not just individual stars in the Milky Way, but entire galaxies containing hundreds of billions of stars each. And in the zone of avoidance, we are missing our view of a huge number of those distant galaxies. For a long time, this did not seem like such a big deal. The universe is vast. There are galaxies everywhere we look. Missing some of them in one particular direction seemed like a minor inconvenience for astronomers mapping the cosmic landscape. But then scientists started noticing something strange. In the 1970s and 1980s, astronomers began making careful measurements of how galaxies move through space, not just how they drift apart due to the expansion of the universe, but how they move relative to each other. These are called peculiar velocities, and they reveal the gravitational influences acting on galaxies. What scientists found was puzzling. Galaxies in our part of the universe were not just drifting randomly. They seemed to be flowing in a particular direction, all of them. The Milky Way, the Andromeda Galaxy, the entire local group of galaxies to which we belong. And beyond that, hundreds and hundreds of other galaxies stretching across hundreds of millions of light years. All of them were moving towards something big, something massive, something with enough gravitational pull to influence the motion of countless galaxies across a vast region of space. And whatever it was hiding in the zone of avoidance. Scientists gave this mysterious cosmic attractor a suitably dramatic name. They called it the Great Attractor. Let that name settle into your mind for a moment. The Great Attractor. It sounds like something from a science fiction story. A cosmic monster lurking in the darkness, pulling entire galaxies toward its hidden lair. In some ways, that description is not far from the truth. The Great Attractor is one of the most massive concentrations of matter in our region of the universe. It lies roughly 200 million light-years from Earth, in the direction of the constellation Centaurus. And it is pulling us toward it at a speed of about 600 kilometers per second. That is over 1 million miles per hour. Right now, as you rest and listen to these words, you are racing through space towards something you cannot see. The entire Milky Way galaxy, with all its hundreds of billions of stars, is being drawn toward this hidden gravitational giant. But here is the thing. For decades, no one could actually see the Great Attractor. We knew it was there because of its effects on the motion of galaxies. We could calculate roughly where it must be and estimate how massive it must be. but the zone of avoidance blocked our view. The great attractor remained hidden behind a curtain of stars and dust. It was like knowing there was an elephant in the next room because you could hear it moving around, but never being able to open the door and see it for yourself. This mystery haunted astronomers for years. What was the great attractor? Was it a single enormous object, a collection of smaller structures, something completely unknown to science? The answers would only come when scientists found new ways to peer through the cosmic fog. You see, the zone of avoidance is only impenetrable to visible light. Our eyes and the optical telescopes that extend our vision can only see in a narrow band of the electromagnetic spectrum. And in that narrow band, dust is very effective at blocking our view. But light comes in many forms: radio waves, infrared radiation, X-rays. Each of these travels differently through the dusty regions of the Milky Way, and some of them can pass through where visible light cannot. Think of it this way. Imagine you are trying to see through a foggy window. Visible light gets scattered by the tiny water droplets, making everything blurry and indistinct. But if you could switch your eyes to see in infrared, suddenly the fog becomes much more transparent. The longer wavelengths of infrared light pass through obstacles that block shorter wavelengths. This is the key to unlocking the secrets of the zone of avoidance. Starting in the 1960s and continuing through the decades that followed, astronomers began surveying the zone of avoidance using infrared telescopes. These instruments could detect the heat signature of objects hidden behind dust clouds. Where optical telescopes saw nothing but murky haze, infrared telescopes revealed a hidden universe of stars and galaxies. One of the early breakthroughs came in 1968, when an Italian astronomer named Paolo Maffei discovered two previously unknown galaxies hiding in the zone of avoidance. These galaxies, now named Maffei 1 and Maffei 2 in his honor, are among the closest galaxies to our own. Yet they had remained hidden for so long simply because they happened to lie behind the obscuring plane of the Milky Way. This discovery was a wake-up call for astronomers. If two entire galaxies could hide this close to us, what else might be lurking in the zone of avoidance? Over the following decades, infrared surveys revealed more and more hidden galaxies. Each discovery added another piece to the puzzle of what lay hidden in our cosmic blind spot. But infrared was not the only tool astronomers had. Radio telescopes proved to be even better at penetrating the zone of avoidance. Radio waves have much longer wavelengths than visible light or even infrared. They pass through dust and gas almost as if these obstacles were not there at all. And galaxies produce plenty of radio emissions, particularly from the hydrogen gas that fills the space between their stars. Hydrogen is the most common element in the universe. It makes up the bulk of the material in stars and the gas clouds between them. And neutral hydrogen atoms emit radio waves at a very specific wavelength, about 21 centimeters. This is called the hydrogen line, or HI line, and it is like a cosmic beacon that radio telescopes can detect across vast distances. By tuning their instruments to this wavelength, radio astronomers could detect galaxies that were completely invisible to optical telescopes. The zone of avoidance, which had been a wall of darkness in visible light, became partially transparent at radio wavelengths. In 1994, astronomers using the Dwingeloo radio telescope in the Netherlands discovered another hidden galaxy. They named it Dwingeloo 1, and it was surprisingly close, only about 10 million light-years away. 2 years later, they found another, Dwingeloo 2. Each discovery revealed that the zone of avoidance was not empty at all. It It was full of galaxies, clusters, and cosmic structures that had simply been hidden from our view. And slowly, the true nature of the great attractor began to emerge. As infrared and radio surveys mapped more and more of the hidden region, scientists realized that the great attractor was not a single mysterious object. It was a vast concentration of galaxies, clusters, and superclusters, all gathered together in one region of space. At the heart of this concentration lies something called the Norma cluster. This is a dense collection of galaxies about 220 million light-years from Earth. It contains hundreds of individual galaxies, all bound together by gravity into a massive cosmic structure. But the Norma cluster is just one part of a much larger picture. To understand what the great attractor really is, we need to zoom out and think about the structure of the universe on the larger scales. The universe is not uniform. Matter is not spread evenly across space like butter on toast. Instead, it clumps together into structures of ever-increasing size. Stars gather into galaxies. Galaxies cluster into groups and clusters. Clusters combine into superclusters. And superclusters connect together through vast filaments of matter that span hundreds of millions of light years. This is called the cosmic web, and it is the underlying structure of the universe. Imagine a three-dimensional spider web, but instead of silk threads connecting at nodes, you have filaments of galaxies connecting at huge clusters, and between these filaments are vast, empty regions called voids, where almost no galaxies exist. The great attractor sits at one of the nodes in this cosmic web. It is a gravitational focal point where multiple filaments of matter come together, and it is part of an even larger structure that astronomers have only recently begun to understand. In 2014, a team of researchers led by astronomer Brent Tully at the University of Hawaii made a remarkable discovery. By carefully mapping the motions of thousands of galaxies in our corner of the universe, they were able to define the boundaries of the supercluster in which we live. They called it Laniakea, which means immense heaven in Hawaiian. Laniakea is enormous almost beyond imagining. It spans about 500 million light-years and contains roughly 100,000 large galaxies. Our own Milky Way sits on the outskirts of this structure, like a small town on the edge of a vast metropolitan region. And at the center of Laniakea, like the drain in a cosmic bathtub, sits the great attractor. All the galaxies within Laniakea are flowing toward this central region, pulled by its enormous gravitational influence. This was a profound discovery. For the first time, astronomers had mapped out our cosmic address. Earth is in the solar system, which is in the Milky Way galaxy, which is in the local group, which is part of the Virgo supercluster, which is itself part of the Laniakea supercluster. And all of it, all 100,000 galaxies, is being pulled toward the great attractor in the zone of avoidance. But the story does not end there. Because as astronomers continued to explore the hidden regions of the universe, they found even more surprises waiting in the cosmic fog. Remember that the zone of avoidance is vast. It covers a huge swath of the sky, and even with infrared and radio observations, exploring it all takes time. The deeper scientists looked, the more they found. In 2016, an international team of astronomers announced a stunning discovery. They had found evidence of another massive supercluster hiding in the zone of avoidance. They called it the Vela supercluster. The Vela supercluster is enormous. It lies about 800 million light-years from Earth, making it more distant than the great attractor. But its size is staggering. Early estimates suggest it might be as massive as the famous Shapley supercluster, one of the largest known concentrations of galaxies in the entire universe. The discovery was led by Professor René Kraan-Korteweg from the University of Cape Town in South Africa. She had spent more than a decade searching this region of the sky, painstakingly gathering evidence of structures hidden behind the Milky Way's obscuring plane. When her team finally had enough data to confirm the Vela supercluster's existence, she described the region as terra incognita, Latin for unknown land. It was an apt description for a cosmic continent that had remained hidden from human knowledge until that moment. The Vela supercluster's existence has important implications for our understanding of the universe. Such a massive structure, lying relatively nearby in cosmic terms, must be exerting its own gravitational influence on the galaxies around it. It may be contributing to the peculiar motions we observe in our cosmic neighborhood. In other words, the great attractor might not be pulling us alone. The Vela supercluster may be adding its own gravitational tug, helping to draw the Milky Way and its neighbors in a particular direction through space. But even the Vela supercluster is not the end of the story. In 2022, another team of astronomers announced the discovery of yet another massive structure hiding in the zone of avoidance. Using infrared surveys that could peer through the cosmic dust, they found evidence of a huge galaxy cluster about 3 billion light-years from Earth. This structure contains at least 58 galaxies bundled together, drawn by gravity into a compact grouping. And because it lies so far away, it must have formed relatively early in the history of the universe, giving scientists a window into how such massive structures come together over cosmic time. These discoveries keep coming. As telescopes improve and survey techniques advance, more and more hidden structures emerge from the zone of avoidance. Each one adds another piece to the puzzle of our cosmic neighborhood. And one of the most powerful tools for exploring this hidden realm is a remarkable telescope located in the remote Karoo region of South Africa. It is called Meerkat, and it is one of the most sensitive radio telescopes ever built. Meerkat consists of 64 large dish antennas spread across the South African landscape. Working together as a single instrument, these dishes can detect incredibly faint radio signals from distant galaxies. And because radio waves pass through the zone of avoidance so easily, Meerkat is perfectly suited to exploring this cosmic blind spot. In late 2024, scientists published results from a Meerkat survey of the Vela supercluster region. The results were remarkable. By detecting the radio emissions from neutral hydrogen in distant galaxies, the Meerkat team discovered 719 galaxies within the Vela supercluster. Less than a third of these galaxies had been known before. The rest were completely new discoveries, hidden behind the Milky Way's obscuring plane until Meerkat's sensitive instruments revealed them. 719 galaxies. Think about that for a moment. Each of those galaxies contains billions of stars. Each potentially hosts countless planets, and all of them were invisible to us until recently, hidden in the darkness of the zone of avoidance. This was just the first detailed survey of the Vela supercluster by Meerkat. Future observations will undoubtedly reveal even more hidden galaxies and help scientists understand the true extent of this massive structure. But Meerkat is just the beginning. It is actually a precursor to an even more powerful telescope called the Square Kilometre Array, or SKA. When complete, the SKA will be the largest and most sensitive radio telescope ever built, with dishes and antennas spread across South Africa and Australia. The SKA will be able to peer into the zone of avoidance with unprecedented clarity. It will map the distribution of galaxies and gas across this hidden region of space, finally completing our picture of the cosmic landscape that surrounds us. As you drift towards sleep, consider what all of this means for our place in the universe. We are not simply sitting still in space, gazing out at a static cosmos. We are in motion. The Earth orbits the Sun. The Sun orbits the center of the Milky Way galaxy. The Milky Way drifts through the local group. And the entire local group, along with thousands of other galaxies, is flowing toward the great attractor at the heart of the Laniakea supercluster. We are part of a cosmic river of galaxies, flowing together through space toward an unseen destination. And yet, in another sense, we are not falling toward the great attractor at all, because the universe is expanding. This is one of the strangest and most wonderful things about our cosmos. Space itself is stretching, carrying galaxies apart from each other over time. This expansion is happening everywhere, at every moment, and it is accelerating, driven by a mysterious force called dark energy. The expansion of the universe works against the gravitational pull of structures like the great attractor. While gravity tries to draw galaxies together, the expansion of space pushes them apart. On small scales, gravity wins. Our local group of galaxies is bound together by gravity. The Milky Way and Andromeda will eventually collide and merge, billions of years from now. The galaxies within dense clusters remain gravitationally bound to each other. But on the larger scales, the expansion of the CT's universe wins. The Laniakea supercluster, despite its enormous mass, is not dense enough to resist the expansion forever. Over billions of years, it will gradually disperse. The galaxies flowing toward the great attractor will never actually reach it. The cosmic river will slow and eventually reverse as the expansion of space carries everything apart. This is the bittersweet fate of our cosmic neighborhood. We are part of a grand structure, a supercluster of 100,000 galaxies flowing together through space. But this togetherness is temporary. In the far future, our cosmic family will drift apart, each galaxy left alone in an ever-emptying universe. But that future is unimaginably far away. For now, we can marvel at the structures that surround us and the mysteries that still await discovery in the hidden regions of the sky. Let us return to the zone of avoidance and think about what else might be hiding there. The discoveries we have discussed so far, the great attractor, the Vela supercluster, the newly found galaxy clusters, represent only what we have managed to find with our current technology. The zone of avoidance still holds many secrets. Remember that this region covers 10 to 20% of the sky. Even with infrared and radio telescopes, we cannot see everything. The densest parts of the galactic plane remain stubbornly opaque, blocking our view even at wavelengths that penetrate dust elsewhere. There could be more superclusters hiding in the darkness. There could be unusual objects or structures that we have not even imagined yet. The zone of avoidance is like a wrapped present that we are slowly unwrapping, one layer at a time. And the tools for unwrapping this cosmic gift are getting better all the time. The James Webb Space Telescope, launched in late 2021, is the most powerful infrared observatory ever put into space. It can see details that previous infrared telescopes could not resolve, peering deeper into dusty regions with greater clarity than ever before. While Webb has primarily been used to study distant galaxies and the early universe, it has also turned its powerful infrared eyes toward our own galaxy. Its observations of the Milky Way's center and the regions obscured by dust are revealing structures and objects that were previously invisible. Webb's infrared vision allows it to penetrate cosmic dust like no telescope before. Where optical telescopes see only darkness, Webb sees stars, gas clouds, and the intricate structures of our galaxy's hidden heart. In the coming years, Webb may help unlock some of the remaining secrets of the zone of avoidance, revealing galaxies and structures that even radio telescopes cannot easily detect. But there is another approach to understanding the zone of avoidance, one that does not require seeing through it at all. Scientists can study the gravitational effects of hidden structures even without directly observing them. By carefully measuring how galaxies move and how light bends as it passes through space, astronomers can infer the presence of mass they cannot see. This is similar to how the great attractor was first discovered. Before anyone could see what was causing it, scientists knew something massive was out there because of its effects on galaxy motions. Today, this technique has become incredibly sophisticated. Astronomers can measure tiny distortions in the shapes of distant galaxies caused by gravitational lensing, the bending of light by massive objects. They can track the subtle motions of galaxies to map out the distribution of matter across space, and they can use computer simulations to fill in the gaps where direct observations are impossible. Through these methods, scientists are building ever more complete maps of our cosmic neighborhood, even in the regions where the zone of avoidance blocks our view. Let us pause here and think about the journey that light takes from the hidden regions of the universe to our telescopes on Earth. Light is the messenger of the cosmos. Everything we know about distant objects comes from the light they emit or reflect. When we look at a star, we are seeing light that left that star years, decades, or centuries ago. When we look at a galaxy, we are seeing light that has traveled for millions or billions of years. The light from the great attractor region has been traveling for about 200 million years. When that light began its journey, Earth was in the Triassic period. Dinosaurs were just beginning to evolve. The continents were still joined together in the supercontinent Pangaea. Think about that for a moment. The light you would see if you looked toward the great attractor tonight left its source when dinosaurs walked the Earth. It has been traveling through space ever since, crossing the vast emptiness between galaxies, passing through the cosmic web, and finally reaching your eyes or your telescope tonight. Avoidance. This is the magic of astronomy. Every observation is a form of time travel. We cannot visit the past, but we can see it. The light brings us images of how the universe looked long ago. The light from the Vela supercluster is even older. That structure lies about 800 million light-years away. Its light began traveling toward us during the Neoproterozoic era, when the most complex life on Earth was simple multicellular organisms. Humans would not appear for another 799 million years. And yet, that ancient light, after its unimaginably long journey, encounters a final obstacle just before reaching us. The Milky Way. The dust and stars of our own galaxy scatter and absorb some of that precious light, preventing it from completing its journey. This is what makes the zone of avoidance so frustrating for astronomers. Light that has traveled for hundreds of millions of years is blocked at the very last moment by our own cosmic neighborhood. It is like sending a letter across the ocean, only to have it lost in the mailroom of the recipient's building. But remember, this blocking is not complete. Some wavelengths of light get through. Infrared light, with its longer wavelengths, can slip past the dust grains that block visible light. Radio waves pass through almost unimpeded. And so astronomers have learned to read these alternative messages from the cosmos. Instead of visible light, they detect infrared radiation. Instead of seeing the colors that human eyes evolved to perceive, They build instruments sensitive to wavelengths far beyond human perception. The universe sends out its information on many channels. When one channel is blocked, we tune into another. This adaptability is one of the great strengths of modern astronomy. We are no longer limited to what our eyes can see. We have extended our senses across the entire electromagnetic spectrum, from gamma rays to radio waves. Each type of light tells us something different about the cosmos. Gamma rays reveal the most violent events, supernova explosions, and the jets from black holes. X-rays show us hot gas in galaxy clusters and the coronas of stars. Ultraviolet light traces young, hot stars and the warm gas between galaxies. Visible light shows us the stars that populate galaxies. Infrared penetrates dust and reveals cooler objects. Microwaves include the cosmic microwave background, the echo of the Big Bang, and radio waves let us see hydrogen gas across the universe. Each wavelength is a window into the cosmos. The zone of avoidance blocks some windows, but not others. And by looking through the windows that remain open, we can still see much of what is hidden. The Meerkat telescope, for example, observes at radio wavelengths around 21 centimeters. At these wavelengths, the zone of avoidance is almost transparent. The dust and stars of the Milky Way scatter visible light, but radio waves sail right through. This is why Meerkat has been so successful at finding hidden galaxies. It is looking through a window that remains wide open even when other windows are closed. The James Webb Space Telescope observes primarily in infrared. Its instruments are sensitive to wavelengths from about half a micron to almost 30 microns. These wavelengths penetrate dust much better than visible light, though not quite as well as radio waves. Webb's advantage is its extraordinary sensitivity and resolution. It can see fainter and more detailed images than previous infrared telescopes. This allows it to study individual stars within dusty regions and to detect galaxies at enormous distances. Together, radio and infrared observations are painting an increasingly complete picture of what lies in the zone of avoidance. Each technique reveals something the other misses. Radio telescopes detect neutral hydrogen gas. Infrared telescopes detect the starlight from galaxies. Combining them gives us a fuller view than either alone. This is the power of multi-wavelength astronomy. By observing the same region of sky at different wavelengths, astronomers can build up a comprehensive understanding of what is there. The zone of avoidance may block visible light, but it is not opaque to every form of radiation. As you drift towards sleep, consider how remarkable this is. Humans evolved to see a tiny sliver of the electromagnetic spectrum. Our eyes are sensitive to wavelengths between about 400 and 700 nanometers. This is what we call visible light, but the universe broadcasts information across a spectrum that is vastly wider. Radio waves can have wavelengths measured in meters. Gamma rays have wavelengths smaller than atomic nuclei. Visible light is just a narrow band in the middle. For most of human history, we were limited to this narrow band. We could only see what our eyes evolved to see. The rest of the electromagnetic spectrum was invisible to us, its information unreachable. Then, in the 19th and 20th centuries, we learned to build instruments that could detect other wavelengths: radio telescopes, infrared cameras, X-ray detectors, gamma-ray observatories. Each new type of instrument opened a new window on the cosmos. This expansion of our senses has revolutionized our understanding of the universe. Objects that were invisible became visible. Phenomena that were unknowable became knowable. The cosmic landscape expanded enormously as we learned to see in new ways. The exploration of the zone of avoidance is part of this larger story. We are using our expanded senses to peer into a region that was once completely hidden. The darkness is giving way to light, or rather, to the many forms of light that our instruments can detect. Let this thought comfort you as you rest. Human ingenuity is slowly illuminating the cosmos. The barriers that once seemed absolute are proving to be permeable. The mysteries that once seemed eternal are gradually yielding their secrets. The zone of avoidance is not truly a barrier. It is a filter, one that blocks some information but not all. And we are learning to read the information that gets through. Now let us think about what the future holds for the exploration of the zone of avoidance. The next few decades promise remarkable advances in our ability to see through the cosmic fog. New telescopes are being built, new techniques are being developed. The hidden regions of the universe will become less hidden with each passing year. The square kilometer array, as we have discussed, will be transformative. Its thousands of antennas and dishes will create the most sensitive radio telescope ever built. It will map the distribution of hydrogen across vast volumes of space, including the zone of avoidance. But the SKA is just one of many new instruments coming online. The Vera C. Rubin Observatory in Chile, formerly known as the Large Synoptic Survey Telescope, will conduct a 10-year survey of the entire visible sky. While it observes in visible light and therefore cannot directly penetrate the zone of avoidance, its all-sky coverage will help astronomers understand the structures surrounding the hidden region. The Euclid Space Telescope, launched by the European Space Agency, is mapping the large-scale structure of the universe using visible and near-infrared light. It will provide the most detailed three-dimensional map of the cosmic web ever made, helping scientists understand the context in which the zone of avoidance structures sit. The Nancy Grace Roman Space Telescope, NASA's next major space observatory after Webb, will conduct wide-field infrared surveys of unprecedented depth. Its observations will complement those of Webb, revealing faint galaxies and structures that lie at the edge of detectability. Each of these instruments will contribute to our understanding of the zone of avoidance. Some will observe directly through the cosmic fog. Others will map the surrounding regions, helping astronomers infer what lies hidden. But perhaps the most exciting developments will come from techniques we have not yet invented. Science has a way of surprising us. New technologies emerge that no one predicted. New methods are developed that open entirely new windows on the cosmos. Who knows what tools future generations will have for exploring the zone of avoidance? Perhaps they will find ways to detect gravitational waves from hidden structures, revealing mass distributions without relying on electromagnetic radiation at all. Perhaps they will develop techniques for reconstructing the hidden regions from subtle patterns in the cosmic microwave background. Perhaps they will invent something we cannot even imagine today. The history of astronomy is full of such surprises. Radio astronomy was born almost by accident when an engineer trying to reduce static in telephone communications discovered signals from the Milky Way. X-ray astronomy became possible only when rockets could carry detectors above Earth's atmosphere. Gravitational wave astronomy was once considered impossible and is now a thriving field. The zone of avoidance that future generations will explore may be very different from the one we know today. Not because the Milky Way will have moved out of the way, but because our tools for seeing through it will have advanced beyond anything we can currently envision. This is one of the joys of science. The future is always brighter than we expect. The mysteries that seem impenetrable today will yield to techniques that do not yet exist. Rest now with this hope in your heart. The universe is being explored. The darkness is being illuminated. The secrets are being revealed one by one, year by year, generation by generation. Let us turn our thoughts now to the peaceful contemplation of our place in the cosmos. You are lying on a small planet orbiting an ordinary star. That star, the Sun, is one of several 100 billion stars in the Milky Way galaxy. The Milky Way is one of roughly 100,000 large galaxies in the Laniakea supercluster. And Laniakea is one of millions of superclusters in the observable universe. These numbers are too large to truly comprehend. Our minds evolved to deal with numbers relevant to survival on the African savanna. Counting predators, tracking food sources, keeping track of group members. Numbers in the dozens or hundreds. But the universe operates on scales vastly beyond our evolutionary experience. Billions of stars, trillions of galaxies, distances measured in light years, each light year representing about 6 trillion miles. When we contemplate these numbers, we are pushing our minds beyond their natural limits. We are using abstract reasoning to grasp realities that no human could ever directly experience. And yet we do it. We build mental models of the cosmos. We create maps and simulations and visualizations. We use mathematics to describe structures that span billions of light years. This is one of humanity's greatest achievements. We have learned to understand things that are utterly beyond our direct experience. We have stretched our minds to encompass the cosmos. The zone of avoidance is part of this vast structure. It is hidden from our direct view, but it is continuous with the parts we can see. The cosmic web does not stop at the boundary of the Milky Way's obscuring plane. It continues through, connecting the structures on either side. When you think about the zone of avoidance, you are thinking about a real place, a region of space filled with galaxies, clusters, and dark matter. A region that is pulling on our own galaxy right now, drawing us toward it at over 1 million miles per hour. This motion is real. You can feel it if you try. Close your eyes and imagine the Earth beneath you. Feel its solidity, its mass, its gravity holding you to its surface. Now imagine that the Earth is in motion. It is orbiting the Sun at about 67,000 miles per hour. The Sun is carrying the Earth around the center of the Milky Way at about 500,000 miles per hour. And the Milky Way is flowing toward the great attractor at over 1 million miles per hour. All of these motions are happening right now. You are moving through space at tremendous speed, carried by the gravitational currents of the cosmos. And yet you feel nothing. The motion is so smooth, so constant, that it produces no sensation. You rest peacefully while the universe flows around you. This is one of the strange and wonderful aspects of physics. Motion is relative. There is no absolute rest. Everything is moving relative to everything else. And within your own frame of reference, sitting still feels exactly like sitting still, no matter how fast you are moving relative to distant galaxies. The zone of avoidance is pulling on you right now. The great attractor's gravity reaches across 200 million light-years of space to give you a tiny tug. The Vela supercluster, 800 million light-years away, adds its own minuscule contribution. These forces are unimaginably weak at the distance we are from them. You cannot feel them. No instrument on Earth could measure your personal acceleration toward the great attractor. But they are real, and they are acting on you right now. You are connected to the hidden structures in the zone of avoidance by gravity, the same force that holds you to the Earth, that keeps the Moon in orbit, that binds galaxies into clusters, stretches across the cosmos, and links everything together. Gravity is the thread that weaves the cosmic web. It pulls matter together across vast distances. It shapes the filaments and nodes that define the universe's structure. It creates the attractors and superclusters that influence the flow of galaxies through space. And gravity does not care about the zone of avoidance. It passes through the dust and stars of the Milky Way as if they were not there. The gravitational influence of the great attractor reaches us unimpeded, even though the light from that region is scattered and absorbed. This is why astronomers first detected the great attractor through its gravitational effects, rather than by seeing it directly. Gravity revealed what light could not. Rest now in the embrace of cosmic gravity. Feel the gentle pull of distant structures, too weak to sense but real nonetheless. Know that you are connected to the hidden regions of the universe, bound to them by the same force that holds the stars in their courses. The universe is one interconnected whole. The zone of avoidance is not separate from the rest of the cosmos. It is part of the same web, the same structure, the same grand design, and you are part of it too. A tiny node in the cosmic web, a brief flicker of consciousness in a universe of mostly dark matter and empty space, but real, connected, part of the whole. Sleep now, cosmic traveler. Let the vast distances and enormous structures fade from your active mind. Let them become a backdrop, a context, a cosmic lullaby that wraps around you as you drift into dreams. The universe will continue while you sleep. Galaxies will flow toward the great attractor. Stars will be born and die. Light will travel across the void, carrying information from distant regions to waiting telescopes. And somewhere, an astronomer will make a discovery. A faint signal from the zone of avoidance will reveal another hidden galaxy. A pattern in the data will suggest another massive structure lurking behind the Milky Way. The exploration never stops. The secrets are always being revealed, and you are part of the species that does the exploring, the revealing, the understanding. This is no small thing. Out of all the matter in the universe, only a tiny fraction has organized itself into conscious beings capable of asking questions about the cosmos. You are part of that fraction. Your curiosity, your wonder, your desire to understand, these are precious and rare in a universe mostly made of hydrogen and dark matter. Dream well tonight. Dream of hidden galaxies and cosmic flows. Dream of the great attractor and the Vela supercluster. Dream of the cosmic web stretching across billions of light years. And when you wake, remember what you have learned. Remember that there is a massive blind spot in our galaxy. Remember that something is inside it. Remember that we are slowly, patiently, generation by generation, learning to see what is there. The universe rewards those who look closely and think deeply. The zone of avoidance has rewarded astronomers with discovery after discovery, the great attractor, the Vela supercluster, hundreds of hidden galaxies revealed by Meerkat. And there is more to come, always more. The universe is infinite in its generosity to curious minds. Sleep now. The cosmos holds you gently in its vast embrace. The stars shine down on your small planet, some of them visible, many hidden behind dust and distance, but all of them real, all of them there, all of them part of the same universe that made you and holds you and will continue long after you are gone. This is the peace of cosmic perspective. Whatever troubles your daily life, whatever worries keep you awake, they are happening on a tiny stage. The universe is vast beyond comprehension, and in that vastness there is room for everything, including your small concerns. Let them go now. Let the cosmos hold them. Let the zone of avoidance, with all its hidden wonders, remind you that there is always more to discover, that the unknown is not threatening but inviting. That mystery is the beginning of exploration, not its end. Good night, traveler among the stars. May your dreams be filled with cosmic wonder. As we continue our journey through this peaceful night, let us think about the scale of what we have been discussing. The Milky Way galaxy is vast. It contains several 100 billion stars spread across a disk about 100,000 light-years in diameter. It would take light itself, the fastest thing in the universe, 100,000 years to cross from one side of our galaxy to the other. And yet the Milky Way is just one galaxy among the roughly 100,000 in the Laniakea supercluster. If you could somehow zoom out and see Laniakea from the outside, the Milky Way would be an insignificant speck on the edge of this enormous structure. The Laniakea supercluster spans 500 million light-years. Light that left one side of Laniakea when the first complex life was emerging on Earth would still not have reached the other side today. And Laniakea is just one supercluster among many. Beyond its boundaries lie other superclusters, other concentrations of galaxies connected by the vast filaments of the cosmic web. The Shapley supercluster, even more massive than the Great Attractor, lies about 650 million light-years away. The Perseus-Pisces supercluster stretches across another region of the sky. These structures, and others we have not yet discovered, make up the large-scale structure of the universe. They are the biggest things that exist, vast collections of matter spanning billions of light-years when taken together. And yet, in the grand scheme of the cosmos, even these structures are just local features. The observable universe extends about 46 billion light-years in every direction. It contains something like 2 trillion galaxies, more than the number of grains of sand on all the beaches of Earth. The zone of avoidance hides a small percentage of this cosmic's wealth from our view. But even that small percentage amounts to billions of galaxies, countless stars, and mysteries beyond counting. Let your mind rest on these numbers for a moment. Let the vastness of the cosmos settle over you like a comfortable blanket. There is something deeply peaceful about contemplating the universe's immensity. Our daily concerns, however important they feel, are happening on a tiny stage within an almost infinitely larger theatre. The problems that weigh on our minds, the worries that keep us awake, all of them are taking place on a small rocky planet, orbiting an ordinary star on the outskirts of an average galaxy that is itself just one mote of light in a supercluster of 100,000 galaxies, itself just one structure among countless others in a universe of 2 trillion galaxies. There is humility in this realization, and there is also comfort. Whatever happens in our lives, the cosmos continues on its grand and patient journey. Stars are born and die. Galaxies drift through space. The universe expands and evolves over billions of years. And through it all, the zone of avoidance keeps its secrets, slowly revealing them to curious minds who develop ever better ways to peer through the cosmic fog. Let us spend some time thinking about what we know and do not know about the region hidden behind our galaxy. We know that the zone of avoidance contains the Great Attractor, a gravitational focal point toward which our supercluster is flowing. We know the Great Attractor is not a single object, but a concentration of galaxy clusters, with the Norma cluster at its heart. We know that the Vela supercluster, a massive structure possibly rivaling the Shapley supercluster in size, lies hidden in the zone of avoidance about 800 million light-years away. We know that new galaxy clusters continue to be discovered in this hidden region. each one adding to our understanding of the cosmic landscape. We know that infrared and radio telescopes can penetrate the zone of avoidance to varying degrees, allowing us to see some of what lies behind the Milky Way's obscuring disk. We know that the James Webb Space Telescope and the Meerkat Radio Array are revealing more hidden structures than ever before, and that future telescopes like the Square Kilometre Array will see even more. But there is still so much we do not know. We do not know the full extent of the Vela supercluster. The densest parts of the zone of avoidance still block our view of its central regions. We do not know whether there are other massive structures hidden in the zone of avoidance that we have not yet detected. Given how much we have found already, it seems likely that more surprises await. We do not know exactly how the gravitational influences of the great attractor, the Vela supercluster, and other hidden structures combine to affect the motion of our galaxy through space. We do not know what lies in the very densest parts of the zone of avoidance, where even radio waves have difficulty penetrating the crowded heart of the Milky Way. These unknowns are not frustrating. They are invitations. Every unanswered question is an opportunity for discovery. Every gap in our knowledge is a place where future astronomers will make their mark. Science is not about having all the answers. It is about asking better questions and finding better ways to seek the truth. The zone of avoidance has been asking us questions for centuries. We are only now developing the tools to begin answering them. As the night deepens and sleep draws near, let us reflect on what we have learned. The zone of avoidance is a region of the sky obscured by our own galaxy. It hides 10 to 20% of the universe from our view in visible light. Within this hidden region lies the great attractor, a massive concentration of galaxy clusters that is pulling our entire cosmic neighborhood toward it at over 1 million miles per hour. The great attractor is the gravitational center of the Laniakea supercluster, our cosmic home. Laniakea contains about 100,000 galaxies and spans 500 million light-years. Hidden deeper in the zone of avoidance is the Vela supercluster, a massive structure that was only discovered in 2016. It may be one of the largest concentrations of galaxies in our region of the universe. New discoveries continue to emerge as astronomers use infrared telescopes, radio observatories, and other tools to peer through the cosmic fog. The Meerkat Radio Telescope in South Africa has discovered hundreds of previously unknown galaxies in the zone of avoidance, revealing the rich structures hidden behind the Milky Way. Future telescopes will see even more, completing our picture of the cosmic landscape that surrounds us. And through it all, we are in motion. Our planet, our star, our galaxy, and our supercluster are all flowing through space, part of the great cosmic dance that has been unfolding since the beginning of time. Think about this motion as you settle into rest. You are not lying still. You are racing through the universe at tremendous speed, carried along by the gravitational currents that flow through the cosmos. And yet you feel nothing. The motion is so smooth, so constant, that it might as well not exist. You rest peacefully while the universe rushes past outside. There is a metaphor here for life itself. We are all moving through time, carried by currents beyond our control. We cannot stop the flow of days and years any more than we can stop the Milky Way's drift toward the great attractor. But within that flow, we can find moments of peace. We can rest. We can reflect. We can marvel at the universe's wonders. The zone of avoidance has been there for as long as humans have looked at the stars. Our ancestors saw the band of the Milky Way crossing the night sky and wondered what it might be. They did not know it was a galaxy, or that we lived inside it, or that it was blocking our view of the universe beyond. Today we know so much more. We have mapped the structures hidden in the zone of avoidance. We have discovered superclusters and gravitational anomalies that our ancestors could never have imagined. We have used technology to extend our vision far beyond what our eyes can naturally see. And yet the mystery remains. The zone of avoidance still holds secrets. The great attractor still pulls us toward destinations we cannot fully see. The universe still has surprises waiting for those patient enough to seek them. This is the beautiful thing about astronomy. No matter how much we discover, there is always more to learn. The universe is so vast, so complex, so full of wonders, that we will never run out of questions to ask or mysteries to explore. Let us take some time now to explore the deeper history of how humans came to understand this cosmic blind spot. The story stretches back further than you might expect, and it reveals much about how science works. The term zone of avoidance was coined by the great American astronomer Edwin Hubble. You may know Hubble as the person who discovered that the universe is expanding, a finding that revolutionized our understanding of the cosmos. But Hubble made many other contributions to astronomy, including systematic studies of how galaxies are distributed across the sky. In the early 20th century, as Hubble and other astronomers catalogued more and more galaxies, they noticed a curious pattern. Galaxies seemed to be distributed fairly evenly across most of the sky. But in a band corresponding to the Milky Way, there appeared to be almost no galaxies at all. At first, some astronomers wondered if this might be a real feature of the universe. Perhaps galaxies simply did not form near large spiral galaxies like our own. Perhaps there was some physical reason why our region of the cosmos was surrounded by empty space. But Hubble realized the truth. The apparent lack of galaxies was not real. It was an artifact of our position inside the Milky Way. The dust and stars of our own galaxy were simply blocking our view of the galaxies that must exist beyond. Hubble called this obscured region the zone of avoidance because astronomers could not study it and therefore avoided it when making maps of the extragalactic universe. For decades, the zone of avoidance remained largely unexplored. Astronomers focused their attention on the clearer parts of the sky, where they could study galaxies without the interference of the Milky Way. The hidden region was treated as a necessary gap in our cosmic maps, an unknown territory that would simply have to wait. But science does not like mysteries to remain unsolved forever. Gradually, new technologies opened windows into the zone of avoidance. The development of infrared astronomy in the mid-20th century was the first major breakthrough. Infrared light, with its longer wavelengths, could penetrate the dust that blocked visible light. When astronomers turned infrared telescopes toward the zone of avoidance, they began to see hints of the galaxies hiding there. The discovery of Maffei 1 and Maffei 2 in 1968 was a landmark moment. Here were two entire galaxies, large and relatively nearby, that had remained unknown simply because they happened to lie behind the Milky Way's obscuring plane. Paolo Maffei, the Italian astronomer who found them, had been conducting an infrared survey of the sky when he noticed these unusual objects. They were clearly extragalactic, meaning they lay beyond the Milky Way, but their presence in the zone of avoidance meant they had escaped detection by optical astronomers for centuries. The discovery sparked new interest in exploring the hidden regions of the sky. If two major galaxies could hide so close to us, what else might be waiting to be found? Throughout the 1970s and 1980s, astronomers continued to chip away at the zone of avoidance. Infrared surveys revealed more hidden galaxies. Radio telescopes detected the hydrogen emissions of galaxies that remained invisible to optical and even infrared instruments. Slowly, a picture began to emerge of what lay behind the Milky Way. It was not empty space. It was a continuation of the cosmic web that astronomers could see in other directions. Galaxies, clusters, and larger structures filled the hidden region, just as they filled the rest of the universe. And then came the discovery of the Great Attractor. In the 1970s, astronomers began studying the peculiar velocities of galaxies in our cosmic neighborhood. Peculiar velocity refers to the motion of a galaxy that cannot be explained by the overall expansion of the universe. It represents the galaxy's motion through space due to local gravitational influences. What scientists found was striking. Galaxies in our part of the universe all seem to have a component of motion in the same direction. They were not just expanding away from each other. They were also drifting together toward a common point. This coherent flow of galaxies could only be explained by an enormous concentration of mass pulling everything toward it. And when astronomers traced the direction of the flow, it pointed directly into the zone of avoidance. The name Great Attractor was coined in 1987 by astronomer Alan Dressler. It captured the mystery of this unseen gravitational giant that was somehow influencing the motion of our entire cosmic neighborhood. For years, the Great Attractor remained one of astronomy's most intriguing puzzles. We knew it was there. We could measure its effects, but we could not see it directly. The breakthrough came gradually, as infrared and radio surveys penetrated deeper into the zone of these we can see, represent only a fraction of the total gravitational influence we measure. This brings us to one of the deepest mysteries in all of cosmology: dark matter. Dark matter is a form of matter that doesn't emit, absorb, or reflect light. It cannot be seen with any telescope, regardless of what wavelength that telescope observes. We know dark matter exists only because of its gravitational effects on the matter we can see. The evidence for dark matter is overwhelming. Galaxies rotate faster than they should if they contained only the stars and gas we observe. Galaxy clusters hold together more tightly than visible matter alone could explain. The large-scale structure of the universe matches the predictions of models that include dark matter, but not models that exclude it. Current estimates suggest that dark matter makes up about 85% of all matter in the universe. Ordinary matter, the stuff of stars, planets, and people, accounts for only about 15%. This means that the Great Attractor's gravitational pull comes primarily from dark matter, not from the galaxies we can see. The Norma cluster and its surrounding structures are just the visible tip of an enormous iceberg of invisible mass. When we look toward the zone of avoidance, we are trying to see not just the hidden galaxies, but also the hidden dark matter. The galaxies are tracers, markers that show us where matter has gathered, but they represent only a small fraction of what is actually there. This is humbling to contemplate. The structures hidden in the zone of avoidance are themselves mostly hidden even when we can see them. The visible galaxies are like the foam on a vast dark ocean of invisible mass. Dark matter remains one of the greatest unsolved puzzles in physics. We know it exists. We know how much of it there is. We know how it clumps together to form the scaffolding on which galaxies build. But we do not know what it actually is. Physicists have proposed many candidates for dark matter particles. Weakly interacting massive particles, called WIMPs, were long the leading hypothesis. Axions, another type of hypothetical particle, have also been proposed. More exotic possibilities include primordial black holes left over from the early universe. Despite decades of searching, no one has ever directly detected a dark matter particle. Experiments deep underground, designed to catch the rare interaction between dark matter and ordinary matter, have come up empty. Particle accelerators have failed to produce dark matter particles. The mystery persists. But even without knowing what dark matter is made of, we can study its effects. And those effects are everywhere in the cosmos, including in the zone of avoidance. The great attractor's pull on our galaxy is largely due to dark matter. The Vela supercluster, that massive structure hiding behind the Milky Way, contains vast amounts of dark matter as well. Every concentration of galaxies we find in the zone of avoidance sits within a much larger halo of invisible mass. In a sense, the zone of avoidance hides two layers of reality from us. First, the dust and stars of the Milky Way hide the galaxies behind them. Second, even when we see those galaxies, we are seeing only a small fraction of the total mass that resides there. The universe is far more hidden than it first appears. Let this thought settle into your mind as you rest. The cosmos contains depths beyond depths, mysteries nested within mysteries. What we can see is only a small part of what exists. And much of what exists remains beyond our current understanding. But this is not cause for despair. It is cause for wonder. The universe has so much more to reveal. Future generations will uncover truths that we cannot even imagine today. The zone of avoidance is just one small example of how much remains to be discovered. Now let us turn our attention to the cosmic web itself. Understanding this structure helps us appreciate what is hidden in the zone of avoidance and why it matters. The cosmic web is the largest scale structure in the universe. If you could somehow zoom out far enough to see the universe as a whole, you would see a vast three-dimensional network of matter stretching in every direction. The web consists of several types of features. Filaments are the long strands of matter that connect denser regions. They are made of galaxies, gas, and dark matter, all stretched into thin structures spanning tens of millions of light years. Nodes are the places where filaments intersect. These are the densest regions of the cosmos, where galaxy clusters and superclusters gather. The great attractor is a particularly massive node in the cosmic web. Walls or sheets are flattened structures where multiple filaments come together in 2 dimensions rather than 3. These vast planes of galaxies can extend for hundreds of millions of light years, and voids are the empty spaces between the filaments and walls. They are not completely empty, but they contain far fewer galaxies than the denser regions. Some voids are so large that they span hundreds of millions of light years. This structure formed over billions of years through the action of gravity. After the Big Bang, the universe was almost perfectly uniform. Matter was spread nearly evenly in all directions, but not quite evenly. Tiny fluctuations, perhaps created during the rapid expansion called inflation in the first moments after the Big Bang, created regions that were slightly denser or slightly less dense than average. Gravity amplified these tiny differences over time. Regions that started with a bit more matter attracted still more matter from their surroundings. Regions that started with a bit less matter lost what they had to their denser neighbors. Over billions of years, this process created the cosmic web we see today. The densest regions grew into the filaments and nodes. The least dense regions became the voids. This process is called hierarchical structure formation. Small structures formed first, then merged to create larger structures. Galaxies formed from smaller building blocks. galaxy clusters formed from galaxies, superclusters formed from clusters. The cosmic web is the end result of this cosmic construction project. It is the grandest pattern in all of nature, a structure that spans the entire observable universe. And a significant portion of this structure is hidden from us by the zone of avoidance. Think about what this means. The cosmic web is our key to understanding how the universe evolved. By mapping its filaments, nodes, and voids, astronomers can test their theories about cosmic history. But if part of the web is hidden, our tests are incomplete. The structures hiding in the zone of avoidance are not separate from the rest of the cosmic web. They are continuous with it. Filaments that we can see on one side of the Milky Way continue through the zone of avoidance and emerge on the other side. The hidden region is not an island. It is part of the mainland. This means that our maps of the cosmic web have a hole in them. A hole that covers 10 to 20% of the sky. A hole that might contain structures as massive as anything we have found elsewhere. The great attractor fills part of this hole. The Vela supercluster fills more of it. But there may be other structures waiting to be discovered. The cosmic web does not care whether we can see it or not. It continues through the zone of avoidance, hiding its secrets behind the obscuring plane of our galaxy. As astronomers continue to explore the zone of avoidance, they are filling in this gap in our cosmic maps. Each new survey, each new discovery, adds another piece to the puzzle. The Meerkat survey that discovered over 700 galaxies in the Vela supercluster region was a major step forward. But it was just one survey of one part of the zone of avoidance. Much more work remains to be done. Future surveys with Meerkat and other radio telescopes will cover more of the hidden sky. The Square Kilometre Array, when it becomes operational, will see even deeper into the zone of avoidance. Infrared surveys continue to reveal galaxies that radio telescopes miss. Slowly but surely, the blank spots on our cosmic maps are being filled in. The zone of avoidance is shrinking, not because the Milky Way is moving out of the way, but because our tools for seeing through it are improving. This is the story of science. Obstacles that seem insurmountable eventually yield to human ingenuity. Mysteries that seem permanent eventually give way to understanding. The zone of avoidance blocked our view for centuries, but we are learning to see through it. Let your mind drift now into peaceful contemplation of the cosmos. Let the vastness wash over you like gentle waves on a quiet shore. You are part of this universe. The atoms in your body were forged in stars that lived and died long before the Earth existed. The heavy elements, carbon, oxygen, iron, were created in stellar cores and scattered across space by supernova explosions. Those atoms drifted through interstellar space for billions of years. They gathered into clouds of gas and dust. They collapsed under gravity to form new stars and planets. And eventually, on one small rocky world orbiting an ordinary yellow star, they came together to form you. You are stardust contemplating the stars. You are the universe becoming aware of itself. And tonight, you are thinking about the hidden regions of the cosmos, the places where even your wandering mind cannot easily reach. The zone of avoidance is one such place, a region blocked by the very galaxy that gave birth to your world, a cosmic blind spot caused by your position inside the Milky Way. But even blind spots can be explored. Even hidden regions can yield their secrets. The history of the zone of avoidance is a history of persistent curiosity overcoming apparent barriers. Edwin Hubble identified the problem and gave it a name. Paolo Maffei found galaxies hiding in the fog. radio astronomers detected signals that visible light could not reveal. And today, instruments like Meerkat and the James Webb Space Telescope are pushing the boundaries of what we can see. Each generation sees more than the last. Each decade brings discoveries that would have seemed impossible before. The zone of avoidance that our grandparents knew was far more mysterious than the one we know today. And the zone of avoidance that our grandchildren will know will be more transparent still. This is the arc of human knowledge. We begin in ignorance. We encounter obstacles. We develop tools to overcome them. And gradually, step by step, we illuminate the darkness. The universe does not easily give up its secrets, but it does give them up, eventually, to those who are patient and clever and determined. Rest now in the knowledge that the cosmos is being explored, that even as you sleep, telescopes around the world are gathering light from distant galaxies. The radio dishes in South Africa are mapping the hidden structures behind the Milky Way, that scientists are analyzing data and making discoveries that will be announced in papers and press releases in the months and years to come. The exploration never stops. The universe never runs out of mysteries. And humans never lose their desire to understand. This is perhaps the most comforting thought of all. Whatever challenges we face as a species, we retain our capacity for wonder. We look up at the stars and ask questions. We build instruments to extend our senses. We share what we learn with each other and with future generations. The zone of avoidance will continue to reveal its secrets. The great attractor will become better understood. The Vela supercluster will be mapped in ever greater detail, and new mysteries will emerge to replace the old ones. The universe is generous with its wonders. It always has more to show us. Sleep now, knowing that the cosmos holds infinite marvels. Dream of galaxies streaming through the void. Dream of the cosmic web stretching across billions of light years. Dream of the hidden regions slowly coming into view. And when you wake, the universe will still be there, vast and ancient and full of secrets, waiting for curious minds to explore its depths. The zone of avoidance is just one example of this endless frontier. It reminds us that even our home galaxy, the Milky Way, can block our view and hide things from us. It reminds us that the cosmos does not easily give up its secrets. It reminds us that there is always something more to discover. As your eyes grow heavy and sleep begins to overtake you, let these thoughts drift through your mind like clouds across a night sky. Somewhere out there, beyond the veil of stars and dust, the great attractor waits. A vast concentration of matter, pulling galaxies toward it across hundreds of millions of light years of space. Somewhere out there, the Vela supercluster stretches across the cosmos, a great continent of galaxies that remained unknown until just a few years ago. Somewhere out there, galaxies we have never seen spin through space, stars we have never counted burn in the darkness, planets we have never imagined orbit in silence. And somewhere out there, future discoveries wait, new structures to be found, new mysteries to be unraveled, new wonders to take our breath away. Let us spend a few more moments together, exploring the wonders that lie beyond what we have already discussed. The universe is a place of extraordinary diversity. No two galaxies are exactly alike. No two stars have precisely the same properties. Every corner of the cosmos holds something unique, something that has never existed before and will never exist again. This diversity extends to the hidden regions of the zone of avoidance. The galaxies lurking behind the Milky Way come in all shapes and sizes. Some are giant ellipticals, smooth balls of ancient stars. Some are spirals like our own Milky Way, with graceful arms sweeping around a central bulge. Some are irregular, chaotic collections of stars without clear structure. Some of these hidden galaxies are actively forming new stars. Gas clouds within them are collapsing under gravity, heating up, igniting nuclear fusion. New suns are being born right now in the zone of avoidance, their light blocked from our view by the intervening dust of our own galaxy. Some hidden galaxies host supermassive black holes at their centers. These cosmic monsters, millions or billions of times the mass of the Sun, consume gas and stars that fall too close. As matter spirals into these black holes, it heats up and releases tremendous energy, creating some of the brightest objects in the universe. We call such objects active galactic nuclei, and some may be hiding in the zone of avoidance. Their energetic emissions might be detectable at radio or X-ray wavelengths, even when visible light cannot escape the cosmic fog. The hidden region of the sky is alive with cosmic activity. Stars are being born. Stars are dying. Galaxies are colliding. Black holes are feeding. The same processes that drive the visible universe are happening in the parts we cannot see. This is an important thing to remember. The zone of avoidance is not a dead or empty region. It is simply hidden from our view. The cosmos continues there just as it does everywhere else, indifferent to whether human eyes can perceive it. Think about all the events happening right now in the zone of avoidance. Somewhere behind the Milky Way, a massive star is exploding as a supernova, briefly outshining its entire host galaxy. Somewhere else, two galaxies are beginning a cosmic collision that will last for hundreds of millions of years. Somewhere else still, a planet is forming in a disk of gas and dust around a young star. All of these events are real. All of them are happening. All of them are hidden from us by the accident of our position inside the Milky Way galaxy. But some of them someday will be discovered. As our telescopes improve, we will detect more and more of what lies behind the cosmic curtain. Future astronomers will look back at our time and marvel at how little we knew about the zone of avoidance, just as we look back at earlier generations and marvel at their ignorance of the universe. This is the nature of progress. Each generation stands on the shoulders of those who came before. Each generation sees further, understands more, and leaves behind a richer legacy of knowledge. The exploration of the zone of avoidance is part of this generational project. We are adding our contributions to a process that began centuries ago and will continue long after we are gone. Let us think now about the larger scales of the universe and how the zone of avoidance fits into the cosmic picture. If you could somehow zoom out far enough, the entire Laniakea supercluster would shrink to a tiny point. Even the cosmic web, spanning billions of light years, would become a faint tracery on the canvas of the observable universe. At the very largest scales, the universe appears to be uniform. No matter which direction you look, on average, you see the same density of galaxies, the same types of structures, the same cosmic web. This uniformity is called the cosmological principle, and it is one of the foundations of modern cosmology. The cosmological principle says that there is nothing special about our location in the universe. We are not at the center. We are not at the edge. We are somewhere in the middle of an enormous cosmos that looks roughly the same from every vantage point. This principle is supported by observations. The cosmic microwave background, that faint glow left over from the Big Bang, is almost perfectly uniform across the sky. It varies by only about 1 part in 100,000 from place to place. This tells us that the early universe was extremely smooth, and that smoothness is reflected in the large-scale structure we see today. The zone of avoidance covers only 10 to 20% of the sky. In the grand scheme of the cosmos, this is a small fraction. The structures hiding there are important for understanding our local cosmic neighborhood, but they do not change the fundamental nature of the universe. From a cosmic perspective, the zone of avoidance is a local inconvenience. It makes it harder for astronomers in the Milky Way to map their surroundings, but it does not affect the universe as a whole. This is worth keeping in mind. The zone of avoidance seems like a great barrier because we live here, inside the Milky Way, where its effects are felt. But an astronomer in a distant galaxy, looking back at our region of space, would not even notice it. The dust that blocks our view is invisible at cosmic distances. Our perspective shapes what we see and what we consider important. The zone of avoidance looms large in our cosmic vision because we happen to be positioned where its effects matter. In another location, other barriers would seem important, while ours would be invisible. This is a reminder of the limits of perspective. What seems overwhelming from one vantage point may be trivial from another. The universe is vast enough to contain many perspectives, and none of them captures the whole truth. Let this thought humble you and comfort you at the same time. Your view of the cosmos is limited. Everyone's view is limited. But together, pooling our observations and insights, we can build a more complete picture than any individual could achieve alone. This is the power of science. It is a collective endeavor. Astronomers around the world share their data, challenge each other's conclusions, and build on each other's discoveries. The exploration of the zone of avoidance involves telescopes in South Africa, Australia, Chile, Hawaii, and space. It involves scientists from dozens of countries, speaking many languages, united by a common curiosity. This global collaboration is necessary because the universe is so vast. No single telescope can observe everything. No single astronomer can understand everything. Only by working together can we hope to map the cosmos and understand our place within it. The discoveries being made in the zone of avoidance are the product of this collaboration. Meerkat, in South Africa, builds on techniques developed in the Netherlands and Australia. The James Webb Space Telescope is a partnership between NASA, the European Space Agency, and the Canadian Space Agency. The square-kilometre array will be built and operated by a global consortium. When you hear about a discovery in the zone of avoidance, remember that it represents the work of many people across many countries. It is a triumph not just of technology, but of human cooperation. And this cooperation will continue. The mysteries of the zone of avoidance will be solved by future generations working together, just as current discoveries build on the work of the past. The torch of knowledge passes from hand to hand, crossing borders and spanning generations. This is perhaps the most hopeful aspect of our exploration of the cosmos. We are not alone in our curiosity. We are part of a global multi-generational project to understand the universe. Our contributions matter, even if we do not live to see their ultimate fruits. Sleep now, knowing that the exploration continues, that even as you rest, others are working, that the collective enterprise of science never stops, never sleeps, never gives up on its quest to understand. The zone of avoidance will yield its secrets, not all at once, not completely, but gradually, discovery by discovery, the hidden universe will come into view, and when it does, we will all share in the wonder. Let us take one last contemplative journey before sleep takes you. Imagine you are floating in space, far above the plane of the Milky Way. Below you, the galaxy spreads out like a glowing disk, its spiral arms sweeping gracefully around the central bulge. From this vantage point, you can see what someone on Earth cannot. You can see through the plane of the galaxy to the universe beyond. The zone of avoidance does not exist for you here. The dust and stars that block Earth's view are beneath you, not between you and the cosmos. Look out at the universe from this imaginary perch. See the galaxies scattered across the void like fireflies in an infinite meadow. See the filaments of the cosmic web, faint traceries of matter connecting the bright nodes of clusters and superclusters. See the great attractor, no longer hidden. It is a vast concentration of galaxies, clusters gathered together in a region where the cosmic web converges. You can see the flow of galaxies toward it, streams of matter slowly drifting in the direction of this gravitational giant. See the Vela supercluster, a massive structure that spans an enormous volume of space. Its galaxies shine with the light of trillions of stars. Its dark matter forms an invisible framework on which the visible matter hangs. See the cosmic web stretching to the horizon in every direction. Filaments and nodes and voids, the largest pattern in all of nature, defining the shape of the universe itself. From this vantage point, the universe seems almost comprehensible. You can see its structure. You can trace its patterns. You can understand, at least in outline, how it all fits together. But this is an illusion. The universe extends far beyond what even this imaginary view can show. The observable universe, the part we can, in principle, see, is just a tiny bubble in what may be an infinite cosmos. Beyond the observable universe, there may be regions we will never see. The light from these regions has not had time to reach us since the Big Bang, and due to the accelerating expansion of the universe, it may never reach us. What lies in those unseeable regions? More of the same, most likely. More galaxies, more clusters, more cosmic web. The cosmological principle suggests that the universe is roughly the same everywhere, but we cannot know for certain. Just as the zone of avoidance hides part of our local universe, the horizon of the observable universe hides infinitely more. Mystery upon mystery, hidden regions within hidden regions. The cosmos seems determined to keep some of its secrets forever. And perhaps that is as it should be. A universe fully mapped and completely understood might be a universe less full of wonder. The mysteries are what drive us to explore, to build telescopes, to look up at the stars and ask questions. The zone of avoidance is one of these productive mysteries. It has challenged astronomers for decades. It has driven the development of new technologies. It has inspired generations of scientists to push the boundaries of what can be observed. Without the zone of avoidance, astronomy would be a different field. Infrared telescopes might have developed more slowly. Radio surveys of galaxies might have been less urgent. The hidden universe would have revealed itself without a struggle. But where is the joy in easy discoveries? The zone of avoidance has made astronomers work for their knowledge. It has demanded creativity, persistence, and ingenuity. And in overcoming its challenges, scientists have developed tools and techniques that benefit all of astronomy. Every obstacle is an opportunity. Every barrier is a chance to innovate. The zone of avoidance has been a demanding teacher, and its students have learned well. Now float gently back down to Earth. Return to your body, to your bed, to the solid ground of your small planet. The imaginary view is gone. The zone of avoidance is back, blocking part of the sky as it has always done. The hidden universe is hidden once again. But you know it is there now. You know about the great attractor and the Vela supercluster. You know about the cosmic web and the flow of galaxies. You know about the telescopes working to reveal what is hidden, and the astronomers who dedicate their lives to this exploration. This knowledge is a gift. It connects you to something larger than yourself. It places your small life in a cosmic context. It reminds you that the universe is vast and full of wonders, most of which remain to be discovered. Carry this knowledge with you into sleep. Let it color your dreams with cosmic imagery, stars and galaxies and superclusters, dust clouds and gravitational flows and hidden structures. And when you wake, remember the massive blind spot in our galaxy. Remember that something is inside it. Remember that we are slowly, patiently learning to see what has always been there. The universe is waiting. The mysteries are calling, and you are part of the story. Good night, traveler. May the stars guide your dreams. The zone of avoidance is not truly a blind spot. It is a challenge, an invitation, a reminder that the universe rewards those who look closely and think deeply. Scientists have not avoided the zone of avoidance. They have embraced it. They have developed new tools and techniques to see through the cosmic fog. They have made discovery after discovery in this hidden region of space, and they will continue. The story of the zone of avoidance is not finished. It is still being written, one discovery at a time. Perhaps someday, future generations will have mapped every galaxy hidden behind the Milky Way. Perhaps the zone of avoidance will become just another well-explored region of the cosmos, its secrets fully revealed. But by then there will be new mysteries to explore, new challenges to overcome, new horizons to chase. The universe will never run out of wonders. That is perhaps the most comforting thought of all. Let us take one more journey through the hidden cosmos before sleep takes you. Imagine you could leave Earth behind. Rise up through the atmosphere, past the space stations orbiting overhead. Continue outward past the Moon, past Mars, past the outer planets. Leave the solar system behind entirely. Now you are drifting through interstellar space. The sun has become just another star behind you, growing fainter as you travel. Ahead, the stars of the Milky Way surround you in every direction. Continue onward. Cross the light years that separate stars. Watch the galaxy's spiral arms unwind around you as you gain perspective. See the great disk of the Milky Way from above, a pinwheel of light hundreds of billions of stars strong. Keep going. Leave the Milky Way behind. The Andromeda galaxy appears in the distance, another great spiral approaching through the void. The smaller galaxies of the local group dot the space around you. Travel further still. The local group shrinks to a collection of points, then fades into the background. You are entering the realm of superclusters now. Vast filaments of galaxies stretch across your field of view. Enormous voids yawn between them. Regions millions of light years across where almost nothing exists. And there, ahead of you, is the great attractor. Not a single object, but a convergence of cosmic flows. Galaxies stream toward it from every direction, drawn by gravity toward this nexus in the cosmic web. You can see the Norma cluster at the center. Thousands of galaxies packed into a relatively small region of space. Around it, other clusters and groups fall inward, merging with the central concentration. This is what has been hiding in the zone of avoidance. This is what has been pulling us toward it for billions of years. But look further. Beyond the great attractor, more structures await. The Vela supercluster looms in the distance, its true extent still uncertain. Beyond that, the Shapley supercluster, one of the most massive concentrations of matter in the known universe. And beyond all of these, the universe stretches on. More superclusters, more voids, more cosmic web stretching to the very edge of the observable universe. From this vantage point, the zone of avoidance seems like such a small thing, just a band of obstruction caused by our position within the Milky Way. The universe beyond it is vast and rich and full of structures that dwarf anything we can experience in daily life. Now let yourself drift back. Return through the cosmic web, past the superclusters and clusters, past the local group, past the spiral arms of the Milky Way, back to our little solar system and our small blue planet. You are home again. The night sky stretches overhead. The Milky Way traces its familiar path across the heavens. But now you know what lies hidden in that band of light. You know about the great attractor pulling us through space. You know about the Vela supercluster waiting to be fully mapped. You know about the hundreds of galaxies that radio telescopes have revealed in just the past few years. The zone of avoidance is no longer a mystery to you. It is a frontier being explored, a hidden realm slowly coming into view. And with that knowledge, let sleep come. Rest now. The universe will continue its grand motions while you dream. The Milky Way will continue its journey toward the great attractor. The expansion of space will continue separating the superclusters from each other. New stars will be born in distant galaxies, while old stars fade and die. The cosmos does not need us to be awake to continue its eternal dance. But when you wake, the universe will still be there. The mysteries will still be waiting. The zone of avoidance will still hold its remaining secrets, inviting future generations to peer through the cosmic fog and discover what lies beyond. For now, rest. Let the rhythm of your breath slow. Let your thoughts drift like galaxies through the void. Let the vastness of the cosmos hold you in its infinite embrace. You are stardust given form and consciousness. You are the universe contemplating itself. And tonight, you have contemplated one of its greatest hidden wonders, the zone of avoidance, the great attractor, the Vela supercluster, names that evoke mystery and grandeur, and beyond them, always more to discover. Sleep well, cosmic traveler. The universe awaits your return. As you drift deeper into rest, one final thought to carry with you. We are lucky to live in an age when these mysteries can be explored. For most of human history, the zone of avoidance was truly unknowable. People could see the Milky Way crossing the sky, but had no idea what it was, or what might lie beyond it. Today, we have infrared telescopes and radio observatories. We have space-based instruments that can see what ground telescopes cannot. We have computer simulations that can model the evolution of cosmic structures over billions of years. Each generation sees further than the last. Each decade brings new discoveries that would have seemed impossible to previous generations. The astronomers who discovered the great attractor in the 1980s could not have imagined the Meerkat telescope finding hundreds of hidden galaxies in a single survey. The scientists who first suspected something massive was pulling us through space could not have dreamed of mapping out the entire Laniakea supercluster. And we, today, cannot imagine what future generations will discover. The secrets that seem impenetrable now will eventually yield to human curiosity and ingenuity. This is the story of science. This is the story of humanity's quest to understand the cosmos we inhabit. We are small creatures on a small planet in a vast universe, but our minds can reach across billions of light years to contemplate structures that dwarf everything we directly experience. This is our gift. This is our wonder. The zone of avoidance blocked our view, and we found ways to see through it. The great attractor hid in the darkness, and we detected its gravitational pull. The Vela supercluster lurked undiscovered for centuries, and we finally revealed its presence. Wherever the universe hides its secrets, human curiosity follows. Whatever obstacles stand in our way, we find paths around them. This should give you hope, not just about astronomy, but about everything. The challenges that seem insurmountable today will yield to patient effort and clever thinking. The problems that appear unsolvable now will find their solutions in time. The future holds discoveries we cannot yet imagine, breakthroughs that will transform our understanding of ourselves and the cosmos. Sleep now with that hope warming your heart. Tomorrow is another day of possibility, another day when human minds will peer into the darkness and bring back light. The zone of avoidance is slowly revealing its secrets, and so too will all the other mysteries that surround us in time, with patience, with effort. Rest well. Dream of galaxies flowing through space. Dream of hidden superclusters waiting to be found. Dream of the endless wonder that is our universe. And when morning comes, remember what lies hidden in our galaxy's blind spot. Remember the great attractor pulling us through the cosmos. Remember that even now, as you sleep, you are racing through space at over 1 million miles per hour toward destinations beyond imagination. The universe is vast and mysterious and beautiful beyond words, and you are part of it. Sleep now, dreamer. The cosmos wraps around you like a blanket of stars. Until next time, when we will explore more wonders of the universe together. But before we say good night, let us linger a little longer in the cosmic twilight. There is more to explore, more to wonder at, more secrets of the zone of avoidance to uncover. Let us think about the tools that have allowed us to see into this hidden realm. The story of exploring the zone of avoidance is really a story about light, about the different kinds of light that exist in the universe and how each one reveals different secrets. When most people think of light, they think of what their eyes can see. The visible spectrum, the rainbow of colors from red to violet that makes up the world of our daily experience. But visible light is just a tiny sliver of the electromagnetic spectrum. It is like looking at a single key on a vast piano that stretches for miles in both directions. Below visible light in frequency are the longer wavelengths. Infrared radiation, microwaves, radio waves. These forms of light have lower energy than visible light, but they travel through the universe in the same way. Above visible light in frequency are the shorter wavelengths, ultraviolet radiation, X-rays, gamma rays. These high-energy forms of light reveal the universe's most violent phenomena. Each type of light tells us something different about the cosmos, and each type interacts with dust in different ways. The dust that fills the plane of the Milky Way is made of tiny particles. Think of them as cosmic smoke, swirling between the stars. These particles are typically made of carbon or silicates, the same kinds of minerals that make up rocks here on Earth. When visible light encounters these dust particles, it gets scattered or absorbed. The blue light gets scattered more than the red light, which is why the dust makes objects behind it appear redder than they really are. Astronomers call this interstellar reddening, but at longer wavelengths, something different happens. Infrared light has wavelengths longer than the tiny dust particles. It can slip past them like ocean waves flowing around small rocks. The dust that blocks visible light becomes almost transparent to infrared. This is why infrared astronomy has been so crucial to exploring the zone of avoidance. Telescopes that see in infrared can look through the dusty veil and glimpse what lies beyond. The progression of infrared astronomy over the decades has been remarkable. In the early days, infrared observations had to be made from high-altitude locations or from aircraft flying above most of Earth's atmosphere. Water vapor in our atmosphere absorbs infrared light, making ground-based observations difficult. Then came space-based infrared telescopes. The Infrared Astronomical Satellite, launched in 1983, was the first space telescope to survey the entire sky in infrared. It discovered hundreds of thousands of new objects and revealed structures in our galaxy that had been invisible before. Later came the Spitzer Space Telescope, launched in 2003. Spitzer carried more sensitive instruments than IRAS and could see fainter and more distant objects. It made crucial observations of the zone of avoidance, revealing galaxies hiding behind the Milky Way. And now we have the James Webb Space Telescope. Webb is the most powerful infrared observatory ever launched. Its enormous mirror, over 6 meters in diameter, collects far more light than any previous infrared telescope. Its position far from Earth keeps it cold, which is essential for sensitive infrared observations. Webb's infrared vision can penetrate dust clouds that would be completely opaque at visible wavelengths. It has already made stunning observations of regions hidden by cosmic dust, from star-forming nebulae in our own galaxy to the center of the Milky Way itself. While Webb was not designed specifically to explore the zone of avoidance, its capabilities are well suited to this task. Future observations may reveal hidden galaxies and structures that even the most sensitive ground-based and previous space-based telescopes could not detect. But infrared is not the only key to unlocking the zone of avoidance. Radio astronomy provides another powerful tool. Radio waves have even longer wavelengths than infrared. They pass through dust and gas as if these obstacles were not even there. The zone of avoidance, which is a barrier to visible and even some infrared light, is almost completely transparent to radio waves. This makes radio telescopes ideal for mapping the hidden regions of the sky. The hydrogen line at 21 centimeters wavelength has been particularly useful. Hydrogen is the most common element in the universe. It makes up the bulk of the gas in and around galaxies. And neutral hydrogen atoms naturally emit radio waves at this specific wavelength. By building telescopes sensitive to this wavelength, astronomers can detect hydrogen across vast distances. And where there is hydrogen, there are usually galaxies. The challenge with radio telescopes has traditionally been resolution. Radio waves have such long wavelengths that achieving sharp images requires enormous telescopes. A single-dish radio telescope would need to be kilometers across to see as sharply as a backyard optical telescope. The solution is interferometry. By linking multiple radio dishes together and combining their signals, astronomers can create a virtual telescope as large as the distance between the dishes. This technique allows radio astronomers to achieve remarkable resolution while keeping the size of individual dishes manageable. Meerkat uses this technique brilliantly. Its 64 dishes, spread across the South African landscape, work together as a single instrument. The result is one of the most sensitive radio telescopes in the world, capable of detecting faint signals from galaxies billions of light years away. The Meerkat survey of the Vela supercluster region demonstrated the power of this approach. By detecting the hydrogen emissions from hundreds of galaxies, it revealed the rich structures hiding behind the zone of avoidance in unprecedented detail. And Meerkat is just a stepping stone to something even more powerful. The Square Kilometre Array, or SKA, is currently under construction in South Africa and Australia. When complete, it will be the largest and most sensitive radio telescope ever built. The SKA will have thousands of dishes and antennas spread across vast distances. In South Africa, 133 meerkat-style dishes will be combined with thousands of smaller antennas. In Australia, hundreds of thousands of low-frequency antennas will cover large areas of the outback. Together, these instruments will collect radio waves from across the cosmos with sensitivity far beyond anything we have today. The SKA's ability to map the distribution of hydrogen across the universe will transform our understanding of cosmic structure. It will detect galaxies too faint for current telescopes to see. It will trace the cosmic web across billions of light-years of space. And it will peer into the zone of avoidance with clarity we can only imagine today. Future maps of the hidden universe, made by the SKA and its successors, may finally reveal everything lurking behind the Milky Way, the great attractor, the Vela supercluster, and whatever else hides in the cosmic fog will be laid bare for astronomers to study. But for now, mystery remains, and there is something beautiful in that mystery. Let us contemplate what we do not know. The great attractor has been studied for decades, yet we still do not fully understand it. We know it is a concentration of galaxy clusters centered on the Norma cluster. We know it is the gravitational center of the Laniakea supercluster. We know it is pulling us toward it at tremendous speed. But questions remain. How much mass does the great attractor really contain? Estimates vary widely depending on the methods used to calculate them. The gravitational effects we observe suggest a certain amount of mass, but the galaxies we can directly detect account for only a fraction of this. Where is the missing mass? Some of it is surely dark matter, the invisible substance that makes up about 85% of all matter in the universe. Dark matter interacts with other matter through gravity, but does not emit or absorb light. It is hidden not just in the zone of avoidance, but everywhere. But is dark matter the whole answer? Could there be other explanations for the great attractor's pull? Some scientists have proposed alternative theories, though none have gained widespread acceptance. The true nature of the great attractor remains a puzzle awaiting solution. And then there is the Vela supercluster. Discovered only in 2016, the Vela supercluster is one of the largest structures found hiding in the zone of avoidance. Yet we know relatively little about it. The densest core of the Vela supercluster lies behind some of the most obscured parts of the zone of avoidance. Even radio telescopes struggle to see into this region. The stars and gas of the Milky Way are so thick there that signals from behind get confused and scattered. We know the Vela supercluster exists. We know roughly how big it is and where it lies. But its exact structure, its total mass, and its influence on our cosmic neighborhood remain uncertain. Future surveys with Meerkat, the SKA, and other instruments will gradually fill in these gaps. Astronomers are already planning observations that will probe deeper into the Vela supercluster than ever before. But for now, it remains largely unexplored territory, a cosmic continent whose outline we can just barely see. And beyond the Vela supercluster, what else might be hiding? The zone of avoidance is large. It covers about 15% of the sky on average, though the exact percentage depends on what wavelength you are observing. In some directions, the obscuration is worse than others. Wherever the zone of avoidance is thickest, the potential for hidden structures is greatest. There could be galaxy clusters we have not detected. There could be massive concentrations of matter whose gravitational effects we have not yet measured. The universe is under no obligation to place its most interesting structures in the parts of the sky we can easily see. Some of the most important pieces of the cosmic puzzle may be hiding right where the view is worst. This is both humbling and exciting. humbling because it reminds us how limited our vision of the universe truly is, exciting because it means there are discoveries waiting to be made. The zone of avoidance is not a flaw in the universe or a failure of our telescopes. It is an opportunity, a frontier, a reminder that exploration is never finished. Let us think about what these hidden structures mean for our understanding of the cosmos. The universe is not smooth and uniform. Matter clumps together on every scale, from planets and stars to galaxies and superclusters. This clumping creates gravitational wells that attract more matter, which creates deeper wells, which attract still more matter. On the larger scales, this process creates the cosmic web. Filaments of galaxies stretch across millions of light years, connecting dense nodes where clusters and superclusters gather. Voids between the filaments grow emptier as their matter drains away toward the denser regions. The great attractor and the velar supercluster are nodes in this web. They are places where cosmic matter has gathered in unusual concentration. Understanding these nodes helps us understand how the universe evolved. After the Big Bang, the universe was almost perfectly uniform. The matter was spread nearly evenly in all directions, but tiny variations, quantum fluctuations frozen into the fabric of space, provided seeds for structure formation. Over billions of years, gravity amplified these seeds. Regions that were slightly denser than average attracted more matter and became denser still. Regions that were slightly less dense lost matter and became emptier. By studying the structures that resulted from this process, astronomers can test their theories about how the universe evolved. The distribution of galaxy clusters, the size of superclusters, the shape of the cosmic web, all of these provide clues about the physics that govern the early universe. But if parts of this web are hidden from our view, our picture is incomplete. The zone of avoidance could contain structures that change our understanding of cosmic evolution. There could be unusually large concentrations of matter that challenge our models. There could be unusual void regions that do not fit expected patterns. Until we fully map what lies behind the Milky Way, we cannot be certain our theories are correct. This uncertainty is part of science. We build models based on what we can observe, knowing that future observations might reveal something unexpected. The zone of avoidance is a constant reminder that our models are provisional, always subject to revision as new data comes in. And this is as it should be. Science advances by testing ideas against reality. The hidden structures in the zone of avoidance will eventually provide powerful tests of our cosmological theories. As we drift deeper into the night, let us return to the question of motion. We have talked about the great attractor pulling us through space, but what does this motion actually mean? And should we be worried about where we are heading? First, let us be clear about the numbers. The Milky Way galaxy, along with everything in it, including you, is moving toward the great attractor at about 600 kilometers per second. That is about 1.3 million miles per hour. This speed is mind-boggling by everyday standards. The fastest spacecraft humans have ever built, the Parker Solar Probe, reaches speeds of about 430,000 miles per hour as it skims close to the Sun. We are moving 3 times faster than that, just by sitting still. But in cosmic terms, this speed is rather modest. Light travels at about 186,000 miles per second. At our speed toward the great attractor, it would take us about 340 million years to travel just 1 light year. The great attractor lies about 200 million light years away. At our current speed, we would need roughly 70 billion years to reach it, but we will never actually reach it. The expansion of the universe is carrying the great attractor away from us at the same time we are being pulled toward it. On the larger scales, expansion wins, so there is no need to worry about colliding with anything in the great attractor region. The cosmic dance we are part of will continue for billions of years, with the expansion of space gradually separating the structures we are flowing toward. But the motion itself is real. Right now, as you rest, you are racing through the cosmos. The Sun is carrying you in its orbit around the Milky Way. The Milky Way is carrying you through the local group, and the local group is flowing toward the great attractor as part of the Laniakea supercluster. All of these motions add together. Depending on which direction you consider, you might be moving faster or slower through the cosmic reference frame. Astronomers measure all of these motions relative to the cosmic microwave background, the faint glow left over from the Big Bang. This radiation fills the universe uniformly and provides a natural reference point against which to measure motion. When we measure our motion relative to the cosmic microwave background, we find the combination of all our velocities. We are moving at about 630 kilometers per second in a direction toward the constellation Leo. This total motion includes our orbit around the Milky Way, the Milky Way's motion within the local group, and the local group's flow toward the great attractor. Everything added together gives us our cosmic velocity. Think about this for a moment. Every motion you have ever experienced, walking across a room, driving a car, flying in an airplane, is layered on top of this enormous cosmic velocity. You are always moving at hundreds of kilometers per second, even when you feel perfectly still. The universe has no absolute rest. Everything is in motion relative to everything else, and we are all part of this great cosmic flow. Let your mind settle into this idea. Let the motion become comforting rather than unsettling. You are flowing through the universe like a leaf on a gentle stream. The currents are vast and ancient, but they carry you smoothly through the cosmic night. As sleep approaches, let us consider one more aspect of the zone of avoidance story. We have focused on what lies hidden in this region. The galaxies, the superclusters, the mysterious great attractor. But the zone of avoidance is also a reminder of where we are, of our place in the cosmos. We see the zone of avoidance because we live inside the Milky Way galaxy. The same disk of stars that makes our night sky beautiful also blocks our view in certain directions. If we lived outside the Milky Way, looking at it from afar, we would see it as a spiral galaxy not unlike many others. We would see its bright core and graceful spiral arms. We would not experience the zone of avoidance at all. But we do not live outside. We live inside. We are part of the Milky Way, embedded in its disk, surrounded by its stars and dust. This gives us a unique perspective. We can study our own galaxy from within, observing details that would be impossible to see from outside. The individual stars, the gas clouds, the stellar populations and their ages. But this insider perspective also has limitations. We cannot see our galaxy from the outside. We can only piece together its structure from the view we have from within. And in one direction, that view is blocked by our own galactic home. The zone of avoidance is the price we pay for living inside a galaxy. It is a consequence of our cosmic address. But what a wonderful address it is. The Milky Way is a beautiful spiral galaxy, home to several 100 billion stars. Our solar system occupies a pleasant spot in the suburbs, far enough from the crowded center to enjoy relative peace, close enough to be part of the galactic community. We have neighboring galaxies to study. We have the vast cosmic web stretching in every direction we can see. We have mysteries like the zone of avoidance to challenge and inspire us. If we could choose any location in the universe to call home, we could do far worse than where we are. Some galaxies are so isolated that their inhabitants, if they existed, would see almost nothing beyond their own galaxy. Some galaxies are so close to large clusters that their stars are being stripped away by gravitational forces. Some galaxies are colliding with neighbors, their structures torn apart by cosmic violence. The Milky Way is peaceful by comparison. We are part of a modest group of galaxies, not too crowded, not too isolated. We have a clear view of much of the universe, with only the zone of avoidance partially blocking our sight. And that partial blindness, it has driven us to develop remarkable technologies, infrared telescopes, radio observatories, techniques for seeing what visible light cannot show us. The zone of avoidance has made us better astronomers. It has pushed us to think creatively about how to observe the universe. It has given us mysteries to solve and discoveries to make. In a way, we should be grateful for the zone of avoidance. It has enriched our understanding of the cosmos by challenging us to overcome its obstacles. Now let us take one final tour through the hidden universe before sleep claims you. Start with our position. In the cosmos, you are on Earth, a small rocky planet orbiting an ordinary yellow star. The Sun is about 26,000 light-years from the center of the Milky Way, located in a region between two spiral arms. Zoom out. The Milky Way is a barred spiral galaxy, about 100,000 light-years in diameter. It contains somewhere between 100 and 400 billion stars, depending on how you count the faint ones. The Milky Way is part of the local group, a collection of more than 50 galaxies held together by gravity. Our nearest large neighbor is the Andromeda Galaxy, about 2.5 million light-years away. In about 4 billion years, the Milky Way and Andromeda will begin to collide and eventually merge into a single, larger galaxy. Zoom out further. The local group is a small part of the Virgo supercluster, a collection of about 100 galaxy groups and clusters spread across 100 million light-years. But wait, the Virgo supercluster is itself just a piece of something larger. The Laniakea supercluster encompasses the Virgo supercluster and much more. It contains about 100,000 large galaxies spread across 500 million light-years. At its center lies the great attractor, the gravitational focal point toward which all of Laniakea's galaxies are flowing. And hidden in the zone of avoidance, just beyond Laniakea, lies the Vela supercluster, still being mapped, still being understood. Another massive structure in our cosmic neighborhood. Beyond these nearby structures, the universe stretches on. The Shapley supercluster, about 650 million light-years away, is one of the largest concentrations of galaxies known. The Perseus-Pisces supercluster, the Coma supercluster, the Sloan Great Wall, stretching for over 1 billion light-years. And these are just the structures closest to us. The observable universe extends about 46 billion light-years in every direction. It contains roughly 2 trillion galaxies. The cosmic web spans it all, a vast network of filaments and nodes that defines the largest scale structure of everything that exists. Somewhere in all of this, behind the veil of the zone of avoidance, secrets still wait. Galaxies uncounted, clusters unmapped, perhaps structures no one has yet imagined. The universe is large enough to hold endless mystery. Rest now in that vastness. Let the scale of the cosmos dwarf your daily concerns. Whatever troubles your mind, remember that you are part of something inconceivably grand. The atoms in your body were forged in ancient stars. The calcium in your bones, the iron in your blood, The oxygen you breathe, all of it was created in stellar furnaces billions of years ago. You are literally made of stardust. The same elements that make up galaxies and nebulae and the hidden structures in the zone of avoidance also make up you. In a very real sense, you are the universe contemplating itself. Your curiosity about the cosmos is the cosmos being curious about itself. Your wonder at the stars is the stars wondering at their own existence. Sleep now, knowing you are part of all of this. The cosmic flows that draw galaxies toward the great attractor also shape the matter from which you are made. The same physics that governs the formation of superclusters governs the beating of your heart. You are connected to the universe in ways both physical and profound. The zone of avoidance may hide parts of the cosmos from our telescopes, but it cannot hide the fundamental truth that we are all part of the same cosmic story. Dream now of galaxies drifting through the void. Dream of superclusters gathering at the nodes of the cosmic web. Dream of the great attractor, patient and invisible, exerting its pull across hundreds of millions of light years. Dream of the Vela supercluster, a cosmic continent still being explored. Dream of the Meerkat telescope in South Africa, its 64 dishes pointed at the stars. Dream of future telescopes that will reveal what remains hidden today. Dream of astronomers working through the night, adding one more piece to the puzzle of the universe. Dream of the countless questions still waiting to be asked and the discoveries still waiting to be made. The universe is a place of endless wonder. The zone of avoidance is just one of its many mysteries, and mysteries are what make life interesting. Tomorrow, the cosmos will still be there. The stars will still shine. The galaxies will still flow toward the great attractor. And somewhere, someone will make a discovery that changes our understanding of everything. But for now, rest. Let the cosmic currents carry you gently through the night. The universe has been unfolding for nearly 14 billion years. It will continue for billions more. There is no need to understand everything tonight. Sleep is its own kind of voyage. Your mind will drift through landscapes as strange and wonderful as anything in the cosmos. Your dreams may take you to places no telescope can see. And when you wake, the universe will be waiting, ready to reveal a little more of itself, ready to challenge you with new questions, ready to fill you with wonder all over again. This is the gift of consciousness. We get to experience the universe. We get to wonder about its mysteries. We get to feel small in the face of its vastness and brave in our attempts to understand it. The zone of avoidance has been hiding secrets for as long as humans have looked at the stars, but we are slowly learning to see through the darkness. Generation by generation, telescope by telescope, discovery by discovery, we are mapping the hidden cosmos. And that is a beautiful thing. Good night, traveler. May your dreams be filled with starlight and wonder. May you wake, refreshed and curious about the universe around you. And may you never lose the sense of awe that comes from contemplating the vastness of space and time. The cosmos is waiting, the mysteries are calling, and you are part of it all. Sleep well. Until next time, when we will continue our peaceful journey through the wonders of the universe. Thank you for joining me tonight. If this video brought you peace and wonder, please like it and subscribe to the channel. Your support helps bring more cosmic journeys to those who seek them. Good night, and may the stars light your dreams.